friends, today we are going to study some definitions, some properties and examples from practice set 2.2. Our first definition is of irrational numbers. Which is called as irrational number? Number which is not rational is called as irrational number. But the exact definition of this irrational number is the numbers whose decimal representation is non-terminating and non-recurring are called as irrational numbers. For example, here square root of 2, square root of 5, square root of 10. म्हणजे थोडक्यामध्ये जे परफेक्ट स्क्वेअर नंबर्स नाहीत त्यांचे स्क्वेअर रूट जे आहेत these are all irrational numbers. The set of irrational numbers is denoted by q complement or it is also called as q dash. We know that set of rational numbers it is denoted by q. So here set of irrational numbers is denoted by q complement. Now if we find the square root of 2 by our division method, last year you have studied how to find the square root using division method. So here if we find the square root of 2 using division method, you will find that its square root is equal to 1.4142 and so on. After this decimal point, the digits are unending. So this is non-terminating type of decimal. Also it is non-recurring. म्हणजे याच्यातला कोणतीही संख्या किंवा कोणताही संख्यांचा एक विशिष्ट गट पुन्हा पुन्हा रिपीट होत नाही. So it is non-recurring. Also it is non-terminating and therefore square root of 2 is irrational number. Also root 5, root 10 यांचे सुद्धा जर आपण स्क्वेअर रूट काढले तर आपल्याला या ठिकाणी अशा प्रकारे त्यांचे स्क्वेअर रूट मिळणार आहेत. त्यामुळे या संख्यांना आपण irrational numbers असे म्हणतो. Let us prove that root 2 is an irrational number. To prove that root 2 is an irrational number, we use indirect proof. Means, let us assume that root 2 is a rational number. So, when root 2 is a rational number, root 2 is equal to, it will be in the form P by Q. So, here P and Q have a common factor that is 1 because it is in the reduced form. There is no any common factor other than 1. So here squaring both sides, square of root 2 is 2, p square upon q square. So 2 is equal to p square upon q square. 2q square is equal to p square. Now p square is even. Therefore p is also even, means 2 is factor of p. Call it as equation number 1. Now let p is equal to 2t. Therefore again squaring, p square is equal to 4t square. 2q square is equal to 4t square. Since p square is equal to 2q square, so q square is equal to 2t square. Q square is even and therefore q is also even, means 2 is again factor of q. Call it as equation number 2. From 1 and 2 you will find that 2 is a common factor of p and q. But it was in the reduced form and there was no any other common factor other than 1. So here we get contradiction. This is contradictory because our assumption is wrong and therefore root 2 is irrational number. Now let us see some properties of irrational numbers. First property is addition or subtraction of a rational number with irrational number is an irrational number. Second property is multiplication or division of a non-zero rational number with irrational number is also an irrational number. And third property is addition, subtraction, multiplication and division of two irrational numbers can either be rational or irrational numbers. Now next is real numbers. We know that the collection of numbers we get by putting together rational numbers as well as irrational numbers. The collection is called as collection of real numbers. Means every rational number is real number. Also every irrational number is a real number. Also here the numbers which are represented by points on a number line are real numbers. So here every point on the number line is associated with a unique real number. Also every real number is associated with a unique point on a number line. Now solve some examples from practice set 2.2. First example is show that 4 root 2 is an irrational number. So for this one, let us assume that 4 root 2 is a rational number. 4 root 2 is a rational number. Therefore, 4 root 2 is equal to a upon b, where b is not equal to 0 and a and b are a comma b are integers. A comma b are integers. Now take this 4 to right hand side. Here root 2 is equal to a upon 4b. Now see here carefully. We shall call this as equation number 1. In this equation number 1, right hand side of this equation is a rational number because integers are rational numbers. But what about left hand side of the equation? Left hand side is root 2 and root 2 is an irrational number. So here we get contradiction. Here RHS or right hand side of equation 1 is a rational number, and left hand side of the equation 1 is an irrational number. So here we get a contradiction. So this is contradictory. And therefore our assumption that 4 root 2 is a rational number is wrong. Therefore our assumption that 4 root 2 is a rational number is wrong, and therefore 4 root 2 is an irrational number. Root 2 is an irrational number. Similarly, second example is prove that 3 plus root 5 is an irrational number. So again in this example also we shall assume that 3 plus root 5 is a rational number. So let us suppose or let us assume that 3 plus root 5 is a rational number. Therefore, 3 plus root 5 is equal to a upon b, where b is again not equal to 0 and a comma b belongs to set of integers, that is a and b are integers. Root 5 is equal to, we shall take this 3 to right hand side of the equation. So root 5 is equal to a upon b minus 3. Now again we shall call this as equation number 1. If we observe this equation, again right hand side is a rational number because a and b are integers and integers are rational numbers. So here right hand side is rational numbers. What about left hand side? Again left hand side is an irrational number And here also we get a contradiction because our assumption is wrong. So, left hand side of the equation is root 5 is an irrational number, and right hand side of the equation is a rational number. So this is contradictory. Therefore, our assumption plus root 5 is a rational number is wrong. And therefore, 3 plus root 5 is an irrational number. So our third example is represent the numbers root 5 and root 10 on a number line. Root 5 and root 10 are irrational numbers. Now we are going to represent these irrational numbers on a number line. मागच्या वर्षी तुम्ही रूट 2 हा irrational नंबर लाईन वर दाखवला होता. आता या वर्षी आपल्याला रूट 5 आणि रूट 10 हे irrational numbers रिप्रेझेंट करायचे आहेत. So for this purpose, first of all, draw a number line. Let us give name to this line as L. Now here are some points. We shall take here point 0 represents O. Here 2 represents point P and 3 represent S. तर आपल्याला रूट 5 नंबर लाईन वर दाखवण्यासाठी सगळ्यात अगोदर हा जो पॉइंट आहे पॉइंट P, ह्या पॉइंट P पासून आपल्याला 90 अंशाचा कोन काढायचा आहे. परपेंडिक्युलर लाईन काढायची आपल्याला. त्यासाठी आपण अगोदर काय करू, 90 अंशाचा कोन काढू. ड्रॉ ए परपेंडिक्युलर लाईन हियर. अशा पद्धतीने आपल्याला परपेंडिक्युलर लाईन काढायची. त्यानंतर आपल्याला 1 युनिट डिस्टन्स घ्यायचा आहे कंपास मध्ये. आणि हे 1 युनिट डिस्टन्स इज नथिंग बट डिस्टन्स बिटवीन द एनी 2 पॉइंट्स ऑन द नंबर लाईन. So take here 1 unit distance, put one end of metal end here on the point P. So this is your 1 unit distance here. Give name to this as Q. Now join O and Q. So join the points O and Q here like this. Now here formation of right angled triangle. OP is perpendicular to line L. Therefore in right angled triangle OPQ, now by Pythagoras theorem here OQ square is equal to OP square plus PQ square. Now this distance is of 2 units. 2 square is 4. So here 2 square plus this distance is of 1 unit. So that is 1 square. 4 plus 1 is equal to 5. That is OQ square is equal to 5 means OQ is equal to square root of 5. So this distance is root 5 units. Now put one end of compass on this point O. Take O as center and OQ as radius. Draw an arc like this. So here this is your exact position of root 2 on number line. This distance is of 1 unit. So like this we shall represent root 5 on number line. Here is the exact position of root 5. Another one is root 10. Similarly for this square root of 10, again draw angle of 90 degree. Here from this point 3, we shall draw angle of 90 degree here. Again here, take 1 unit distance in your compass, distance between any 2 points, like this. So here is position, exact position, distance from of 1 unit. So let us give to this point as point T. Now join the points O and T. See here, here is also formation of right angled triangle OST. In this triangle OST, by Pythagoras theorem again, OT square is equal to OS square plus TS square. This distance is of 3 units. So 3 square is 9. This distance is of 1 unit. 9 plus 1, 10. Means distance OT is nothing but root 10. Again, with O as center and OT as radius, we shall draw an arc like this. So this is the exact position of the irrational number root 10. In this way, we shall denote these irrational numbers root 5 and root 10 on the number line. Now, the fourth example is write any 3 rational numbers between the numbers given below. So, numbers are 0.3 and minus 0.5. आता आपल्याला ह्या नंबर्स मधले 3 रॅशनल नंबर्स शोधायचे आहेत. त्याच्यासाठी आपण काय करू? सुरुवातीला आपण पहिला रॅशनल नंबर शोधू. त्यासाठी आपण ह्या दोघांची बेरीज करू आणि बेरजेला आपण काय करू? हाफ न डिवाइड करू. या ठिकाणी बघा. सो फर्स्ट नंबर वी शॅल गेट हियर लाईक दिस 0.3 प्लस minus of 0.5 divided by 2. So this is equal to 0.3 plus of minus is minus 0.5 upon 2. So that is equal to 0.3 minus 0.5, that is minus of 0.2 upon 2. That is minus 0.1. So this is first rational number. आणखी आपण काय करू आता? ह्या minus 0.1 आणि 0.3 ह्या दोन्ही मध्ये कोणता रॅशनल नंबर येतो ते बघूया. सेकंड रॅशनल नंबर बघूया आपण त्या दोन्ही मधला आता. minus 0.1 plus 0.3 divided by 2. So this is equal to minus 0.1 plus 0.2, that is 0.3, that is 0.2 upon 2. हे मायनस आणि प्लस असल्यामुळे काय होणार आहे? ह्या 0.3 मधून हा 0.1 मायनस होणार आहे. सो 0.3 minus 0.1 is 0.2 divided by 2 is equal to 0.1. So this is second rational number. आता आपण काय करू? ह्या minus 0.1 आणि minus 0.5 ह्या दोन्हीच्या मधला रॅशनल नंबर शोधू. So third rational number minus 0.1 plus minus of 0.5 divided by 2. So here this is equal to minus 0.1 plus of minus is minus 0.5 divided by 2, that is minus 0.6 divided by 2, that is minus 0.3. 2 3s are 6 here. So which are the rational numbers here? Minus 0.1 comma 0.1 and minus 0.3. These are 3 rational numbers between 0.3 and minus 0.5. second one is find the rational numbers between minus 2.3 and minus 2.33. आता पुन्हा एकदा आपल्याला ह्या दोन्हीच्या मधले 3 रॅशनल नंबर्स शोधायचे आहेत. पहिल्यांदा आपण हे जे मायनस 2.3 आहे त्याला 300 लिहू आणि हे मायनस 2.33 आहे त्याला 330 लिहू. सो ह्या दोन्हीची आपल्याला बेरीज करायची मधला नंबर शोधण्यासाठी आणि त्याच्या बेरजेला आपल्याला काय करायचं 2 न भागायचं आहे. प्लस मायनस ऑफ 2.330 डिवायडेड बाय 2. सो मायनस 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 ऑफ 4.630 divided by 2. So this is equal to minus 2.23 are 6, 2 1s are 2, 2 5s are 10. This is first rational number. आता आपण याच्यातला आणि ह्याच्यातला पहिल्या नंबर ह्या दोन्ही मधला रॅशनल नंबर शोधू. नाउ सेकंड वन minus 2.315 plus minus 2.300. हे दोन्ही मधला आपल्याला आता काय करायचं आहे रॅशनल नंबर शोधायचा. सो सम इज इक्वल टू दोन्हीचे चिन्ह मायनस असल्यामुळे बेरीज काय येणार आहे मायनस 4.3 plus 3 here 615 divided by 2. So this minus as it is minus 2.23 are 6, 0, 2 7s are 14, 2 5s are 10. So this is second rational number. आता आपण काय करू हे minus 2.315 and minus 2.330 यांच्या मधला irrational number शोधू. So third one minus 2.315 plus minus 2.330 divided by 2. So this is equal to minus 4.645 divided by 2. So this is equal to minus 2.23 are 6, 2 2s are 4, 2 2s are 4 and 2 5s are 10. So this is third rational number. So minus 2.315 comma minus 2.3075 and minus 2.3225. These are three rational numbers between minus 2.3 and minus 2.33. Find rational numbers between 5.2 and 5.3. Now we know that there are infinite rational numbers here between the two rationals again. So the numbers are 5.21, 5.22 and 5.23. These are three rational numbers between 5.2 and 5.3. Now fourth one minus 4.5 and minus 4.6. So here also we can easily write the rationals. 4.51 minus 4.52 minus 4.53 and so on. These are the rational numbers between minus 4.51 and minus 4.6.